Good morning. This is the flipped video for our gravitation organizer. So you should be looking at page 4 on the organizer. We left yesterday's class at question 4. So if you remember correctly, we were going to use a mass of 100 kilograms and 70 kilograms, and you were going to figure out the distance between, or the force between them if they were separated by 1 meter. So you should already have these notes in, so I'm just going to put this stuff in real quick. So just hold on. So again, in this problem we have the masses and the radius. We're trying to find force. We're going to use Newton's universal law of gravitation, and this is what all the substitutions look like. When you're all done, you're going to get an answer equal to, when you work that out, you get an answer of 4.7 times 10 to the negative 8 newtons. Alright, so now let's look at the next problem. This is one that we did not get to. So it says, determine the attractive force between blank and blank. So let's just pick a 100 kilogram person, and let's say something really massive, like a building, which would probably be like 1 times 10 to the 6th kilograms. Okay, again, you want to make sure that you're going to use the EE button on your calculator. So again, start setting it up. I'll do the same, so you can certainly pause the video while you're setting up the equation. So again, you see we have the givens here again. We have the force, we have the formula, and then what we're going to do is we're actually going to solve for that, so you can start setting it up. Again, I recommend you use the EE button. And in this case, I would start figuring out the top, write it down, figure out the bottom, write it down, and then divide the top by the bottom. So that's what I'm going to demonstrate here. Okay, so here's the work. This is what it looks like when you substitute in all the numbers with the units. Make sure that you put those units in, there and there. When you figure out the top, you get that. When you figure out the bottom, you get that. And then when you divide the numerator by the denominator, you get this. Okay, so even though the masses are much larger, we still have a really, really small force. So what we're going to do next is we're going to look at something really big, something on the surface of the Earth. Okay, in this next question we're talking about the attractive force between myself, 100 kilograms, and the Earth at 6 times 10 to the 24th kilograms at the Earth's surface. So if you're at the surface of the Earth, you're that far away, 6.4 times 10 to the 6 meters from the surface. So that's going to be my R. So again, you can pause the video, you're going to start putting the numbers in, and I'll meet you at the solution column. Okay, again, here's the variables. We're solving for that. There's our formula for force. Sliding on over, here's the solution, or the start of the solution. So again, units, units, units are very important. So now let's figure out what this actually is. So you're going to figure out the top, write it down, figure out the bottom, write it down. Okay, and when you work it out, you end up getting 977 newtons, which is pretty much my weight on Earth. In fact, the force of gravity between myself and the Earth is my weight. Okay, the last question on here is pretty much a gimme. It says, is the attractive force that the Earth exerts on me larger, smaller, or the same in magnitude as the attractive force that I exert on the Earth? Think of Newton's third law. So they are actually going to be the same, because when you use this formula, it does not matter who's pulling on who. The two poles are going to be the same. They'll just be opposite in direction. Now the big deal is that since I'm so much lighter than the Earth, the force affects me infinitely more than it does the Earth.